of the tsunami in Japan resulted in a number that I've heard of 20 million tons of material being washed into the Pacific. But there are other things at work, practices of aquaculture, utilizing plastic materials in aquaculture that break loose. And then ships at sea. MARPOL, which regulates shipping, is making an effort to try to regulate, but it's very difficult to police a vessel that's thousands of miles offshore and to keep them from doing something irresponsible. And the U.S. Armed Forces recognize that there's an issue with marine pollution. We've actually done some research for the U.S. Army on degradable materials as alternatives to regular plastics. So there are some people beginning to pay attention. This is, in fact, a river in Los Angeles. Yes, I know it's lined with concrete, but that's how Los Angeles does things. They take things that used to look really cool and natural and turn it into something fake. It's called Hollywood. But the Algalita Marine Research Foundation was awarded a grant to do some studying. We decided to understand how much plastic material was leaving the Los Angeles area through the Los Angeles River over a 3-day rainy period. So we pulled enough samples, calculated statistically that we only saw about 2 billion small plastic particles and just over 287 larger plastic particles going down the Los Angeles River in 3 days. 2.3 billion pieces of plastic weighing 60,000 pounds in 3 days. Now, those were rainy days. Doesn't rain in California very much, particularly not in Southern California. But just imagine how much material is getting down there. Where does it go once it gets into the ocean? The gyres is something you're going to hear talked about a little bit more tonight, and the speaker after me is going to tell you, I think, a lot more about it. But there are gyres that occur all over the world. There are 5 major oceanic gyres, several minor. But we've done a lot of work in the North Central Pacific Gyre, and the reason for that is that if you put marker buoys out there and track them, as some people have done, and you look at what happens over years and over time, you can watch and see where those in fact go. You can follow the currents, you can see where they concentrate. And so, because it's one of the closest areas to Long Beach, California, which is our base, you can see the arrow points to our study area. That's still, Marita, about 1,500 miles from shore? So what we find is that area that is a convergence zone because of winds and currents keeps floating materials in an area longer than other parts of the ocean, and so it makes kind of a natural toilet bowl that doesn't flush area for us to study. And so using the ORV Algalita catamaran, which was specially built to do scientific research, we go out in the ocean looking for things like this, which is what we call a little windrow of floating material, and a lot of that flotsam is in fact plastic. But then we take a planktonic type net, a manta trawl, not nearly as gorgeous as those manta rays that David showed us in his pictures, but they try to do the same thing. The big open mouth is towed near the surface. You scoop in because of the square area of the front of the trawl, how fast you're pulling and how long you pull. You can calculate how much water you actually filter. You trap the materials in a cod end of that sampling net, pour them out into a petri dish, dry them, sort them, weigh them, and come up with all kinds of interesting things. But this is a sample that came from the North Pacific Gyre in 1999, or this one actually may have come from a more recent voyage, but we've done several. But that's the type of thing that we get when we pour out of the cod end. It goes into a dish like that. This is what you see in the North Atlantic. You can see obviously some fish, a lot of smaller fish, and then little pieces of plastic, the blue and the red, little piece of film maybe over to the right. You can't see the filaments and things like that, that's in there. The Indian Ocean, another trawl sample. These are typically about a mile long from that manta trawl. The South Atlantic, similar. The South Pacific, and this is more recent, we've finally done this. But again, what we're seeing, and if you look close, a lot of those pieces there are plastic. And until just maybe 6 months or so ago, instead of the word nearly, we would say that over 10 years, every oceanic sample that Algalita has taken contained plastic. We recently did a cooperative study with Terra Expeditions out of France. They're doing a world circumnavigation. And they took some samples for us in the Antarctic Ocean, the most remote ocean on the face of the planet, except for maybe what's under the North Polar ice cap, but still extremely remote. And there are people who said that there are ocean currents and there's a barrier that prevents pollution from getting to the Antarctic. Well, I think all but one of the samples that they got for us from the Antarctic contained bits of plastic. So the ocean is one contiguous world, and there are no fences, there are no boundaries from one part of the ocean to the other. And eventually what we do in one part of the ocean has the potential to move to any other part of the ocean on the face of this planet. So how's it changing with respect to time? Was it smart of Captain Moore to have us begin to look at this as a potential problem? Well, this has a few more numbers than I really like to get into. And really, the arrows that are in red should be white, and the other numbers should be red. And I'll give you just an example of what we've got here. It's a little bit, give me just a little bit here. The leftmost column was taken in 1999, and then you have 2008, 2009, 2 more study voyages that we did to compare. The changes, the far 2 right columns, are the ratio of change. So the uppermost arrow that's pointed down, it says 0.2. That means that there was a 20% decrease in 2009 of the total count of plastic pieces. But if you look to the left of that, in 2008, that was a 230% increase in plastic pieces. That's what that 2.3 means. That's a ratio. And so if you look at all of those, if you look at the plastic to plankton ratio, which is maybe a little bit iffy depending upon what time of day you pull samples and all that stuff, but still, in 1999, we found 5.19 times as much plastic as there was plankton out in the North Pacific subtropical gyre, up to 8.9 in 2008, 890% more. So it is a growing problem, one that we're trying to quantify. Hopefully we get enough people's attention on it and we can make a difference and solve it. Well, we're doing surface samples, but what about underneath? It's very difficult. Some people say that we know more about the surface of the moon than we do the ocean floor, and I believe that's certainly true for a large part of our world's ocean seabed. This is from the south of Crete near Greece. You can see the materials, plastic cups. And this is the Mediterranean Sea floor taken by a remote vessel. Mr. Galgani has done that. You can see the plastic bottles and you can see the bags there. Looks like somebody tossed a bag of plastic water bottles over the side. And that brings up an interesting point. About 50% of plastic is actually heavier than water. So not all of it floats. And some of the lighter plastic materials will actually get encrusted with other things. Their density will increase, and they have the potential to sink as well. And so, what? We've got a bunch of plastic. It's good stuff, right? You know, I take it, I bring my bread home in it. My bread in a plastic bag is inside another plastic bag to keep it fresher. It's inside another plastic bag, which I put in my car. Then when I get done with that, take that plastic bag, take it out when I walk my dog, do my thing when the dog does his thing, pitch it in the trash. Does it really matter? So let's talk a little bit about that. Captain Moore says plastic is both predator and prey. And you've seen pictures like this, and I'm not going to show a ton of these, but there are a couple that I think are significant, and it proves the point. And we're going to talk about entanglement.